So this is a short video on how Gymnasium works on the Gymnasium internals. And to begin with, Gymnasium is just one analyzer projects among others. Currently we have five analyzer projects in GitLab dependency scanning, and yes, Gymnasium is one of them. So I won't cover what's generic about this analyzer, but instead I will focus on what is specific to the Gymnasium analyzer. Also, I won't cover Gymnasium Maven and Gymnasium Python, which both are based on this project. Okay, so let's start with the main function. This is where all things begin. As you can see, it's a command line and in command line interface, and the main command is the run command. It's based on the run command defined in the command library, but again, I won't cover that in this video. Instead, I want to focus on the scan, the core of the scan itself, because that's very specific to Gymnasium, though it's similar to what we have in Bender Audit. Actually, it's pretty similar. So yes, you can see that after finding a compatible project and before converting the output, there's the scan itself, which is instantiating a scanner, and then running the scan here. Oops. Okay, so let's jump to the scanner package. So here it is, scanners package, sorry. The scanner struct is defined here. It essentially instantiates a finder. This is used to find dependency files, and also an advisory repo, an advisory repository. This is where we have the security advisories, sorry. That's the other way around. Instantiating a scanner is about creating a finder, again to find dependency files, and creating a repo, advisory repo, and checking that the security advisory repo provides advisories for all the dependency file parsers we have. We want to fill if the security advisory repo is incomplete. We want to make sure that it covers all the package types for which we have dependency file parsers. Okay, and that's the definition of the parser itself, the scanner itself, sorry. And its main function, well, top level function, scan dir, scan directory. It essentially delegates finding the files, the dependency files to the finder, and then gets a bunch of files, iterates on the files, and then parse the files using the dependency file parsers. That's here. It collects the output, that is the dependencies found in the files, and then for each file, that's a loop here, it finds all the affections. An affection is when an advisory applies to a file, a dependency file, and specifically to a dependency listed in a dependency file. Okay, and so we need to have a look at these two functions. Sorry, parsed reader to better understand how parsing files works, and file affections to see how Gymnasium builds a list of affected files. So let's have a look at parsed reader, which I believe is defined here. Yes, okay. So parsed reader simply delegates the parsing of the file to the parser that has been found. And again, finding the files along with the compatible parsers is delegated to the finder. So I won't cover that in details, but the finders are defined here. Here we got the finder, its tests, and the definition of what is returned by the finder. And as you see, a finder returns a collection of files having a path and a parser, a compatible dependency file parser. Okay, so no more on that. But oops, going back to the scanner, we have here a dependency file parser found by the finder, and we delegate the parsing of the file to the parser, which processes a file reader, IO reader, sorry, and returns a slice of dependencies. And now here we've got an intermediary object, a different kind of file, which combines a path, a package manager. We want to keep track of a compatible package manager like bundler in the case of Ruby bundler, a package type like Ruby because we want to know that these are Ruby dependencies, and a slice of dependencies. And maybe it's time to say some more about the dependencies and the dependency file parsers. So let's have a look. Parsers are defined here. Yes, here we've got the definition, generic definition of the parser. And in the directories, we've got all the available parsers. For instance, we've got gem file that contains a parser for bundler gem files, gemfile.log files actually. Okay, so here it's the definition of the parser, the strict type. A parser provides a parse function, and a parse function takes a reader and returns a slice of dependencies, possibly an error. A dependency is a list of combines a name with a version. So for instance, if you're familiar with Ruby on Rails, the name of the dependency would be Rails, and the version would be 6.0.0 RC1, for instance. That's a dependency. And a dependency file parser returns a package type, and we'll see later on why this is very important. But for now, just bear with me. A package type would be, for instance, gem in the case of Ruby gems. And to illustrate that, let's have a look at this dependency file parser the one we have for gemfi.log. It's defined here. So as you can see, we got a parse function here that processes a gemfi.log. So it means it goes through the lines of the gemfi.log and builds a list of dependencies, ultimately to convert to generic parser dependencies with a name and a version. And the parser is registered here, registered with a name, gemfi, with a parse function. That's the parse function we've seen here. And what else? The package manager, its vendor. That's informative. It's not really used by Gymnasium itself, but it shows up in the UI. The package type would be gem in that case. And again, it's defined here, gem, that's the same constant, and the supported file names. So that's that parser response to gemfi.log and gems.logged. That's the definition of a parser, and it's registered here because that's how it works. We've got a registry where all the dependency file parsers register themselves. So again, all that to say that this is how parsers work, dependency file parsers. Going back to the scanner here, the scanner again delegates the parsing of the file, gets a list of dependencies, a slice actually of dependencies, and again a package type. So for instance, if the file happens to be a gemfi.log, here it's going to be the gemfi parser, which will return a slice of dependencies along with the gem package type. And we'll need the package type in order to resolve the advisories, the dependencies to package advisory, security advisories, along with the names and the versions listed in the dependencies here, depths dependencies. Okay. So here we collect files having dependencies and types. Once we've done that, we move on to the next stage, so to speak, where we list affections for these files. And again, an affection is a security advisory applying to a dependency. And that happens only if the advisory, security advisory, matches the package type, like gem, the package name, like Rails, and the package version, like, I don't know, an old version, which is likely to be affected, like 4.1.2, something like that. Okay, let's move on to this file affections, which is responsible for building a slice actually of affected files. Here it is. So it takes a file and it takes an advisory repo. And maybe it's useful to go back to the definition of the file. A file, again, has a path, as a package type, and as dependencies. And now we want to add affections to these files. Okay, so we loop on the dependencies, and for each dependency, we retrieve the package. Well, we need an intermediary package structure to query the advisory repo here, here, and all that to list the advisories that possibly apply to the package. But we're not sure yet, because here it's just a match based on the package type and on the dependency name. At this point, we don't consider the exact version of the dependency, but we build a list of the path of the advisories that possibly apply to the dependency. In order to know whether a particular security advisory applies to a dependency, we need to perform a query and evaluate the affected range to see if the dependency version belongs to the affected range. And maybe I should show you to an advisory at this point. So I'm gonna jump to the advisory package. So that's a sub-package of Gymnasium that is responsible for handling security advisories. And it defines what is an advisory. It also defines what is a repo. As you can see, an advisory applies to a package here. It provides many information, like it has a title, a description, all that. And it has an affected range. And this is where we need to evaluate a version range in order to know whether the dependency version belongs to the affected range. And just to show you what it looks like, let's jump to the fixtures, because we want realistic advisories. Like here, we've got one, active record. Yep. So here, we've got an advisory, that's the identifier. And that is the affected range. The dependency is affected if its version is greater than that or equal to and lesser than that, 4.2.7.1. That's because this is the fixed version. Okay, so going back to the scanner, again, we're trying to know if a file is affected, a dependency file is affected, and to associate the dependencies contained, well, declared in the dependency file with advisory. And the combination of the two is what we call an affection. So here we collect possible affections. That is a dependency combined with an advisory. And for each affection, we collect queries because we want to resolve the affected range, again, to tell whether a dependency version is affected or not. Okay, so we collect all these ranges and here we process them all in order to, again, to know what are the dependencies that are truly affected. So this is where we need the vrange library. I'll tell more about that later for clarity. Okay, but the main idea here is that it's used to refine and to exclude affections based on the dependency versions. Okay, well, actually, this is what we do here. So all these two blocks of code are used to eliminate dependencies and affections if the dependency version does not belong to the affected range. So for instance, this is where we would exclude a dependency like raise 5.0.0 because it does not belong to the affected range. And here we have the filtered list, and this is what we return. Filtered list of affections here, and we set the affections for each dependency file in the list. So that's the main function of Gymnasium, the scan directory. It ultimately returns a list of files with dependencies and affections and a package type. And again, an affection is a dependency combined with an advisory, a security advisory. Okay, so let's roll back a bit. The scanner is initialized here in the run command of the CLI. That's here. That's a scanner. And here we run scan directory. So the output of the scan, the result of the scan, is not a JSON report we can directly use in independent scanning. So the GitLab wouldn't be able to process that as a dependency scanning report, and it has to be converted. This is what we do here. It has to be converted to a JSON report, but I won't cover that. Instead, I want to say some more about the vrange library, and before that, maybe I should show you the Gemnasium DB. Okay, so it is. Gemnasium DB is a separate repo, so that's not the Gemnasium Analyzer repo, that's another one, and it only contains YAML files, each YAML file being a security advisory. So for instance, in the gem directory, we've got all the security advisories for Ruby gems, and in active record, we've got all the advisories for this particular package, active record, and here I believe that's the one we had in the fixtures for the tests of Gemnasium itself. So yeah, that's pretty much the same. So internally, Gemnasium uses this Gemnasium DB repo. This is where it finds its advisories. Okay. And a bit more on the vrange library, but not too many details. The vrange library is here. It's a collection of plugins because the syntax, the version syntax, depends on the language and the package manager. So for instance, here the affected range is compatible with Bundler and Ruby gems. That wouldn't be that would be different for Maven, for instance. So if we go to Maven, to a security advisory affecting a Maven package, like this one, you can see that the affected range is different. So the syntax really belongs to the package manager and ultimately to the package type. So that's a Maven syntax for version ranges. Okay, all that to say that we need plugins, and these are the plugins. No matter what the plugin is, it implements this resolver interface. And a VRange resolver takes exposes a resolve function that takes a query and returns a result set. And a query, I'll take that one too. A query is a range and a version. So for instance, a query would be, does 3.9.0 belong to this? The answer would be no. Another query would be, does version 3.7.0 belong to that? And the answer would be yes. And see, here we've got the result. To get the result, you submit the query again, like does 3.7.0 belong to what we've seen before? And the answer would be yes. I won't get into details, but that's how we run queries in batch mode. Yes, that's because of the implementation. We need to do that for performance. Okay, I think we've covered pretty much everything. You know why we have this advisory subpackage. This is the package we need to manipulate the security advisories. You also know why we have this scanner package. That's the one responsible for finding the dependency files supported by Gymnasium and parsing them using the parsers, and ultimately building a list of affections. You also know why we need this VRange library. That's the library we use to tell whether a given version, dependency version, belongs to an affected range. And I won't cover that. That's for auto remediation. And I won't cover that either. Convert, again, is used to convert the output of scandir to a standard JSON report, a dependency scanning JSON report. And that's it. Thank you.